Bismillahirrahmanirrahim. I am Abdullah from Department of Electronics Engineering, University of Engineering and Technology, Texas. Today I will be presenting my research article named as Soft Computing Approach for Classification of Complex Power Quality Events. Topics that I will be covering in my presentation are introduction, literature review, methodology, results, and in the end conclusion. Introduction. Electric power quality, also known as power quality, includes both voltage and frequency. A power supply quality is rated as excellent if it remains stable within a defined range. No real power supply is ideal, as the power sector has become more complex due to the new technologies entering the business. These new technologies introduce new problems to the grid. Almost all latest electrical networks, linear and non-linear loads, and semiconductor devices generate deviation in ideal conditions of the supply, that is, pure sinusoid. These deviations are generally known as power quality disturbances. To explain the importance of issues relating to power quality, we may conclude that poor power quality results in excessive power and economic waste. Two perspectives can be addressed for discussing the causes of poor power quality. The first is the sources of utility, and the second one is internal. It imposes financial pressure on customers and suppliers. Unstable voltage and frequency also generate disturbance via transmission lines in the power flow, and its overall effect can affect all kinds of facilities like high cost, medium cost, and low cost. Following figure shows different types of facilities categorized by cost that are influenced by the quality of electricity. Extensive literature review has been carried out, but some important researches are discussed here. In first article, researchers propose a model that can be used to identify the power quality events located in the power distribution system. This technique is based on the use of wavelet transform and radial based function neural networks. Secondly, in 2016, the authors proposed a novel method to identify and recognize power quality instabilities of basic nature by utilizing S-transform and decision support rules. Similarly, in 2018, wavelet-based sport vector machine classifier was used for detection and classification of power quality disturbances with 96% accuracy of classification. In 2020, a research named as Evolving Disturbances Detection and Classification in Real Time for Grid-Connected Systems was carried out with the help of improved principal component analysis and one-dimensional convolution neural networks. In this research, 9 types of power quality events have been analyzed, and it includes one normal and 8 mixed power quality events. These can be shown in Table 1. The integral model has been implemented in the MATLAB software. This software representation of the model comprises a function to generate PQ disturbances automatically. Distortions have been generated with the following parameters: 1,000 samples of each class has been generated. Sample frequency has been set to 10 kHz, and fundamental frequency of the signal is 50 Hz. All the parameters of the power quality distortions are set as per the standard alternating current supply. Each class of power quality distortion can be visualized here. To generate power quality disturbances, an experimental setup has been established in the laboratory. Figure shows the block diagram of the setup. A MATLAB data file has been generated based on the mathematical models of distortion given in the previous table. Data has been generated in the form of signals that then the data in the then the data in the form of the digital signal has been fed to digital to analog converter, which converts the data in analog signal, which is given as input to the signal processing stage. Usage of this stage removes any type of noise from signal, and after noise removal, features are extracted. On the basis of these features, classification is being performed, and finally, the classified results are passed to the power quality detection and monitoring module, where distortion is being detected and displayed. Expression of features may also reduce the number of recurrent data needed for a given evaluation, reducing the data and the efforts of the computer to create variable combinations also increases the performance of training and generalization phases in the machine learning model. The efficiency of power quality disturbance signal classification is achieved by selecting the feature vector. Time domain features to which maximum accuracy has been achieved are listed below, that are standard deviation, energy, total harmonic distortion, mean frequency, S-kurtosis, average frequency, and total. Now we have the most important part of our research, that is classification. While choosing a classifier, it is important to consider various factors for the reliability of the implemented diagnostic scheme. Various factors must be considered, so we depend on supervised learning strategy. In the suggested technique, the ensemble-based tree framework is used to identify the PQD signals. As Beijing is founded on the concept of an ensemble made up of classifiers developed on Bootstrap replicates of the training dataset that should be randomly generated. The testing set of data is categorized into subgroups by Bootstrap cross-validation, and every segment is used as testing data to build individual decision trees. As bootstrapping number determines the quantity of developed trees, and outcomes of decision trees trained via multiple subgroups are added to the majority voting scheme. It is assured that the majority vote improves independent results. The base tree classifier block diagram can be seen in the figure. Now we'll move towards result and discussion portion. In order to achieve improved results for the detection of power quality disturbances through power quality signal analysis, extensive experimentation was carried out. Feature selection is done by comparing various configurations of features to portray PQDs and pure sinusoidal signals. This detailed experimentation leads to the determination of effective and least number of feature of representation which contain high discriminating factors between both categories. Following table offers information about the feature assessment process verified for a range of classification methods. On the basis of a tenfold cross-validation methodology, the classifier is trained and assessed. Experiments were carried out on different classifiers which include all the decision trees and sport vector machines. The findings of the classification achieved after extensive testing and experimentation can be found in the table. The study of five different classifiers indicates that the base tree has achieved the highest accuracy. Figure reflects the assessment of the class-wise accuracy obtained by the confusion method. This gives us 96.30% accuracy. In the end, I would conclude by observing stats and statistical outcomes shows that even under noisy conditions, our proposed method can efficiently, accurately, and reliably detect and identify various PQD signals and attain a high detection accuracy, better convergence property, and less training time. It is a framework that is cost effective and simpler to use and has a convenient functionality. A more precise and consistent solution could result from an increase in the number of distortions in the future. As it is at its early stage, there are still drawbacks to this approach. Here we have the references of the literature of the research articles that are presented in literature review. Thanks for your listening.